This is section 13.4, which is hopefully not too bad a section. A lot of the concepts such as velocity, acceleration, speed are similar to before in Calc 1, perhaps. All right, so 13.4, motion in space, velocity and acceleration, page 870. Okay, so box number 2, velocity is r prime, the derivative of the distance function. Limit h approaches 0, r of t plus h minus r of t over h. You don't really need that. Just r prime is the first derivative, and acceleration is the second derivative. So page 871, a of t is v prime or r double prime, as we know. Speed is the the magnitude of the velocity vector. So speed is not a vector, but it's a scalar. So what's the difference? You can say 50 miles an hour that way, or 50 miles an hour that way, or 50 miles an hour that way. That's a vector. But if you just say 50 miles an hour, there's no direction attached to it. So we just take the magnitude of the velocity vector for the speed. So that's fairly straightforward. Okay, so here's a position function. The velocity is the first derivative, which means you take 3 derivatives. Acceleration is the second derivative, take 3 derivatives. And then the speed is simply the absolute value, or the magnitude, I should say, of the velocity vector. So first derivative, second derivative, magnitude of v. Okay, so what could be simpler? Okay, the only other thing that's sort of new, and there's only the problems at the end that deal with this, are the tangential and normal components of acceleration. Okay, so here's the picture. Oops, try to get this focused. All right, so here's the acceleration vector, which could be proportional to force, as we know, Newton's second law, F equals ma. So acceleration is proportional to force. Okay, sometimes you want to break it up into a tangential component and a normal component. Okay, and we have formulas for that, as it turns out. Okay. All right, so what you want is on page 875, box 9, a sub t tangential component is r prime dot r double prime over magnitude of r prime. And in number 10, a sub n is the magnitude of r prime cross r double prime over magnitude of r prime. Okay, so all you really need is from here to here. You don't need the in-between stuff. Okay, tangential component and normal component, just go, ignore all this stuff, just go straight to here. Notice they're similar in that they both have the magnitude of r prime, and on top they both have some product of r prime and r double prime. Here it's a dot product, here it's a cross product, which gives you a vector, and then you take the magnitude, right? So box 9 and 10, put those on your formula sheet. Tangential component, normal component of acceleration. All right, and that's pretty much about it. All right, so 13.4, page 878. I'll show you these problems here. So velocity, acceleration, and speed should not be that big a deal. And some more problems over here. And then tangential and normal components over here. All right. So problem 3, a 2-dimensional vector. R of t is -1/2 t squared t. Okay, plug in t equals 2. Plug in 2 there, -2, 2. Okay, so that's the point that you're at. Okay, r prime of t, the derivative is -t1. Plug in 2, -2, 1. Acceleration vector, second derivative. So -1, 0. Or you can just say -i. Okay, and what's the speed? By formula, it's the magnitude of the velocity vector. So square root of t squared plus 1, t squared plus 1. And what's the speed at t equals 1? Just plug in 1 and you have radical 2. Okay, so the speed is radical 2, but we would say the velocity vector is -1, 1. That's a direction involved in it also. Okay, and here's some pictures. X equals -1/2 y squared How do I get that? Well, if you look over here, that's X, that's Y. So if you just pretend that's Y, and it's a parabola opening this way. So the position vector is -2, 2, and the acceleration vector is -I. It's just pulling one unit to the left, like so. All right, 7, 3-dimensional, t squared 2, t equals 1. Position vector, just plug in 1, 1, 1, 2. Velocity vector, differentiate, which means take three derivatives. 1, 2, t, 0. Plug in 1, 1, 2, 0. Acceleration vector is a second derivative, so 0, 2, 0, or 2j. Speed is the magnitude of velocity vector, so square root of 1 squared plus 2t quantity squared, 4t squared plus nothing, and plug in 1, radical 5. And here's a little picture, first octant view. Okay, so remember the vector r, position vector, always emanates from the origin. Okay, velocity vector was 1, 2, 0, looks like that. Acceleration vector is 0, 2, 0, pulling that direction. Okay, 11, r of t is this stuff. So the derivative means take three derivatives, radical 2, e to the t, negative e to the negative t. So that's a velocity vector. Acceleration vector, second derivative, nothing, e to the t, e to the negative t. And the speed is the magnitude of r prime. So it's square root of this thing squared is 2, this thing squared is e to 2t, this thing squared is e to the negative 2t. Very conveniently, this factors into e to the t plus e to the negative t quantity squared, whose square root is e to the t plus e to the negative t. All right, a of t is 2, 0, 2t. V of 0 is 3, -1, 0. R of 0 is 0, 1, 1. So to go from acceleration to velocity, I integrate 2t plus c1. Integral of 0 is a constant, c2, t squared plus c3. Now v of 0, that means when you plug in 0 here, here, and here, okay, you're supposed to get the vector 3, -1, 0. So that means c1 is 3, c2 is -1, and c3 is 0. So v of t is now 2t plus 3, -1, and t squared. Integrate again to get r. So t squared plus 3t plus c4. Integral of -1 is -t plus c5. Integral of t squared is t cubed over 3 plus c6. Once again, if you plug in 0, 0, 0, 0, 0, then you have the vector c4, c5, c6, which comes out to be 0, 1, 1 that was given. Therefore, c4 is 0, c5 is 1, and c6 is 1. So just plug them back in. So r of t is t squared plus 3t plus nothing, -t plus 1, and 1/3 t cubed plus 1. Okay. 19, you're given r of t is this. R prime is 2t, 5, 2t minus 16. The speed is the magnitude of this. So f of t is the square root of 4t squared plus 25 plus 2t minus 16 squared. You're asked to minimize this quantity. Okay. And if you're trying to minimize this quantity, it's probably easier to minimize the square of the quantity. In other words, just get rid of the square root. Okay. Whatever t minimizes this will be the same t which minimizes this. So just look at this. G of t is 4t squared plus 25 plus 2t minus 16 quantity squared. If you clean up that algebra, you get a parabola which opens up, which means basically find the vertex. So G prime is 8t plus nothing plus 2 times 2t minus 16 to the first power times 2. That comes to be 8t plus 8t minus 64 equals 0, which solves to t equals 4. So the answer is t equals 4. And I already know it's a minimum because it's a parabola opening up. Okay, then 39. R of t is cosine t sine t t. R prime is negative sine t cosine t 1. R double prime is negative cosine t negative sine t 0. I need the dot product, r prime dot r prime. That times that is sine t cosine t. That times that is negative sine t cosine t. That times that is 0. Add them all up, you get 0. Okay. which means R prime and R double prime are orthogonal. That's beside the point. Okay, then I need the cross product, ijk, negative sine t, cosine t1, negative cosine t, negative sine t0. So the I component is nothing minus a minus sine t. J component is the opposite of that minus that, nothing minus cosine t, minus a minus cosine t. And the K component is sine squared minus a minus cosine squared, which is 1. The magnitude of that is the square root of sine squared plus cosine squared plus 1, radical 2. Then I need the magnitude of R prime. So magnitude of R prime is the square root of sine squared plus cosine squared plus 1, which is radical 1 plus 1, radical 2. So by formula, put that on your formula sheet. A sub t, tangential component, is dot product divided by magnitude of R, 0 over radical 2, 0. And a normal component is magnitude of cross product over magnitude of R prime, radical 2 divided by radical 2. And so the answer is just simply 1. Right? So that's how to find tangential and normal components of acceleration for one particular problem. All right, so that is it for section 13.4.